In this lesson, we are going to talk about some properties of a triangle. Now, there are lots of properties that we are not going to cover, but in this lesson, we'll just cover 4 of the many properties that do exist. So, we're going to start off with one of the most straightforward ones, and hopefully you actually learn this one in grade 9. So, let's say we have triangle A, B, C, and let's say we are going to draw the median from vertex A. So you know what? Let's draw that point. Let's say this is the midpoint of BC. Remember, and let's say the midpoint of BC is D. Okay, so that's the midpoint, and I'm gonna use my ruler. So remember, median, how to draw one is starting from the vertex, and it joins the midpoint of the opposite side. Okay, so we have the median from vertex A. So the first property has to do with the median of the triangle. What's so special about the median of a triangle? So maybe you learned this from last year. So median bisects the area of a triangle. Well, what does that mean? What does bisects the area of the triangle? Basically, it splits the area into perfect halves. So if triangle ABC has an area of 10 square centimeters, then triangle ABD and triangle ADC both have areas of 5 square centimeters. And why does that make sense? Well, it makes perfect sense because the area of a triangle is base times height divided by 2. So if you think about the triangle of ABD and compare with ABC, well, triangle ABD and ABC have the same height, but the base is halved. So if you keep the same height but you have the base, of course the area is half of that, of the original, right? So let's look at triangle ADC. Same height, half the base. So it makes perfect sense that you are halving the area. Okay, so that's the first property. So that one I would argue is one of the easier ones. Now, not that the next ones are hard, it's just this first one you should have seen in grade 9. Alright, so what about the next one? Let's draw, or let's label triangle ABC. This time, you know what, we're going to keep going on this little median talk. So we're going to keep drawing the medians. So this is, once again, median from vertex A. Bam. So this is median from vertex C, let's say right there. That looks pretty good. Well, that was horrible. Even with the ruler, I messed up. Sorry, let's try again. Okay. And then let's try here about, that looks about right. Nope, that was not good. Oh, this is atrocious. You know what? I hope yours looks a lot prettier than mine. Yeah, this one looks really far off, but I had to draw it this way because I know the medians intersect at a point. And I told you that before. But before I go on, let's call this D, E, F. Let's call this G, okay? The point where they intersect. So, the point where they intersect, where the medians intersect, is has a special name, which is called the centroid, okay? So, medians of a triangle intersect at a point called the centroid. And the centroid has a lot of cool properties, but we're just going to talk about one of them, okay? Centroid divides the length of each median in a 2-to-1 ratio. Okay, so for example, BE is a median, right? BE is the median from vertex P. So the length of BG is twice of that of GE. The length of AG is twice of that of GF. CG is twice of that of GD. Okay, that's how you know it always divides in 2-to-1 ratio. I know my drawing is not beautiful, but yeah, it's true. Okay. All right. So that was the second property. Let's talk about the third property. So this one, you know what? We did medians. Let's draw some right bisectors. Okay. Once again, we talked a bit about this in the previous lesson, but I'm hoping, I'm crossing my fingers. This one's really hard to draw, so I'm a little panicking right now. All right. So whatever happens, happens, right? Let's see. So let's say this is the midpoint. Okay, now this has to be a right angle. That just does not look pretty. I think it's because that other, I'm going to erase that other right bisector. I'm going to try to draw the right bisector of BC a bit better. Oh yeah, that's going to be way prettier. Ooh, that's okay, we can live with that, right? Well, you're gonna have to. Let's see, I finished my markings. Okay, let's say this is D. Let's say this is E, F. Let's say this is G. Okay. So, these are right bisectors. Okay, so I have the right bisector of each of the three sides of the triangle. Now, there's one thing I didn't mention about right bisectors in the lesson video, but I actually mentioned it in the homework video. But I'll say it again, just in case you missed it. So what's special about the right bisector? So let's say I have line segment AB here, okay? And I have the right bisector of AB. So how do you draw the right bisector? Well, it's perpendicular to it and it bisects AB. So what is special? One of the very nice things about the right bisector is that every single point on the right bisector is equidistant to the endpoints, in this case A and B, right? Now, why does that make sense? Because look what I've just drawn when I connect the dots. I've drawn an isosceles triangle, right? So no matter how you do it, you're going to draw isosceles triangles, which makes sense because we know that every point on the right bisector is equidistant to the endpoints. So this makes this point, by the way, it's called the circumcentre. This makes the circumcentre very special. Let's think about it. This here, this is the right bisector of BC. So every point on this line is equidistant to B and C. This is the right bisector of AC, which means every point on this line is equidistant to A and C. This line right here is the right bisector of AB, which means every single point on this line is equidistant to A and B. Well, what about where the right bisectors intersect? Then this must mean it's equidistant to A, B, and C. Isn't that special? So in addition, so I'm going to write some things down and then we'll talk about it. So the right bisectors, or you can call them perpendicular bisectors. The right bisectors intersect at a point called the circumcentre. We learned that in one of our previous lessons. The circumcentre is the center of the circumscribed circle. Whoa, circumscribed circle. Where these words are just coming out of nowhere. So what is a circumscribed circle? It's the circle that you draw that basically goes through A, B, C. Okay, it goes through A, B, and C. Ooh. So I've been practicing my drawing with my kids, so hopefully this pays out. Or pays off, sorry. Oh boy. So I'm trying to draw the circumscribed circle. Okay, we're gonna live with that. So you can only draw one circle, okay? And it makes sense you only draw one circle because there's only one point which is equidistant to A, B, and C. This must be the center of the circle, okay? This must be a center because this distance, distance of length of AG, GC, and GB, that's the radius of the circle, okay? So there is no other point. For example, this cannot be the center of the circle right here, even though it's on the right bisector, because this point is equidistant to A and C, but it's not equidistant to B, right? So it has to be G. It makes perfect sense based on what we know about a circle. G, where the right bisectors intersect, has to be the center of the circle. Okay, so you just add some fancy words: circumscribed circle, circumcentre. But at the end of the day, this is just the center of the circle that's created by points A, B, and C. That's all you really need to know. Okay, all right, last one. Okay, so we have triangle A, B, C. So I'm going to draw D and E. What is D and E? Well, point D is found because it's the midpoint of AB. Point E is the midpoint of AC. And you know what I'm going to do? I am going to join the two midpoints. And if I join the two midpoints of the triangle, that line segment has a special name. Well, it joins the midpoints, so we're going to call it the midsegment. And what's special about the midsegment? The midsegment is parallel to the third side. And not only is it parallel to the third side, it's half the length. Now, if we fast forward to the 7th chapter in this course, you realize that triangle ADE and triangle ABC are similar triangles. And if you knew that, then you can prove that DE must be parallel to BC and also half the length. But basically, you can come back to this little tidbit after you're done the 7th chapter, or at least the first lesson of the 7th chapter. Okay, so by the way, you also have seen this in grade 9. It's in the textbook. The midsegment is parallel to the third side and half its length. Okay, so you know what? Let's do some examples. In example 1, we have triangle ABC with the given vertices A, B, and C. They tell us that D is the midpoint of AC and E is the midpoint of BC. Line segment DE must be called the, well, we're joining the midpoints, D and E, so this line segment is called the midsegment. Okay, and we know how the midsegment is special. We just talked about it. We're just verifying, okay? So we already know that the midsegment is parallel to the third side and half its length. But you know what? We're just going to show that it's true. I'm going to, since they gave us a beautiful picture here, or a beautiful grid, I'm going to make use of it. So 1, -2. B is 9, -6. And C is 5, 2. Okay, let's connect the dots. All right, so verify the midsegment D is parallel to side AB. So I have to show that the two have the same slope, but guess what? I need to find the midpoints first. So D, E, so I have to find D first. So D is the midpoint of AC, so 1 + 5/2, -2 + 2/2, which is 3, 0. What about E? E is the midpoint of BC, so 9 + 5/2, -6 + 2/2, which is 7, -2. Okay, so I have the two midpoints. Let's plot these. DE 7, -2. And connect the dots. Might as well use a picture to its fullest extent. You know what? They do look parallel. But you know what? You can't just look at the picture. They're parallel. You have to verify using the algebra, right? So slope of DE, so it's going to be -2 minus 0 and 7 minus 3. That's going to be -2 over 4, which is -half. Okay, what is the slope of AB? Slope of AB is -6 minus I even said -6. -6 minus -2 and 9 minus 1. That's going to be -4 over 8, which is -half. Nice. Since slope of AB is equal to slope of DE, guess what? AB is parallel to DE. Done. Next one, verify that the length of DE is half the length of side AB. Okay, well, we'll have to find the length of DE and AB. Luckily, I have the rise and the run already. So for DE, it's going to be 4 squared plus -2 squared. So that's 16 and 4, which is 20. How about AB? AB is 8 squared plus -4 squared, which is 80. Now in grade 11 you work with square roots more and you can simplify this radical, but since you don't have that skill set, it's really hard to know that this is half. So we're going to use our calculator to help us out. So I'm going to find what this is. What does the calculator say? Oh, half. Okay, so since it's half, so since this length of DE is half of that of AB, then we verified it. The length of midsegment DE is half the length of AB. Okay, so that's one property. Let's do another one. Verify, so you have triangle ABC, verify that the centroid P 5, -2 divides a median from B in a 2-to-1 ratio. Okay, so let's draw a picture. On the test, it's up to you. If you don't want a picture, go ahead. Don't give yourself a picture. And as I'm plotting these points, I realize, wait a minute. This is the same triangle as we worked with example 1. So 5, -2, this is P right here. And we know this is D here from the previous example. In the previous example, it said line segment A, the midpoint of AC is D. Okay, okay. So verify that the centroid divides the median from vertex B in a 2-to-1 ratio. So we already know it's true, we just have to verify. Now this question is actually not that bad. They want us to verify that the centroid divides the median in a 2-to-1 ratio. They didn't say verify the centroid is located there, okay? Because that would take a lot longer. Because I have to solve for the equations of medians and find a way to intersect. Anyways, so I just have to show PB, peanut butter, is twice the length of PD. So let's do it. Find length of PB. PB, let's see, PB, so 9 minus 5. And -6 minus -2. So that's 4, that's -4, that's 32. And then what else we have? We said PD. Okay, PD. So, ooh, do we have D? Yeah, we forgot D. In our first example, we did the midpoint calculation. D was 3, 0. Okay, you can go back in the video and see how I found D, okay? but D is 3, 0. Okay, P is 5, so it's 5. Let's say 3 minus 5. And 0 minus negative 2. And then let's say 2, 4, 8. Okay, so once, unfortunately, we don't know how to work with square roots very well. So what I'm going to do is take root 32 and divide by root 8. And if you do use your calculator, you'll see it's 2. So since this ratio is 2, therefore centroid divides median from vertex B. In fact, it divides all the medians in a 2 to 1 ratio. Okay. All right. Let's do one more example. All right. For example 3, we have a major hospital will be constructed to serve 3 towns located at the following coordinates. Okay. Verify that the hospital should be located here in order to be equidistant from all 3 towns. So you have to remember, when is this point equidistant to all 3 points there? Well, it's only equidistant to A, B, and Z if this is the point where the right bisectors intersect. This is where the right bisectors intersect. So you just have to verify that's the point. So you're basically checking this is the circumcentre. I'm not gonna use the Cartesian plane here, but if you want, sure, go ahead, check, plot the points. But you know what? I just have to find the equations of the right bisectors, and then I have to do one more step. I don't want to spoil it, but I think you can see where we're going. Right bisector of AB, right bisector of BC. So I only need to do 2 of the 3, okay? You don't need to do all 3. Just find where 2 of them intersect, and the third one must also intersect there. Okay, so we're to find this midpoint of AB. What's the midpoint of AB? Let's see, negative 10 plus 0. Ooh, these numbers are really pretty. 4 plus 8, so negative 5, 6, bam. Okay, and then slope of AB, let's see, 8 minus 4, 0 minus negative 10, that's going to be 4/10, which is 2/5. Okay, so therefore the perpendicular slope is negative 5/2. So y equals mx plus b, let m equals negative 5/2, sub in the point negative 5, 6. Oh, please, by the way, please don't make a careless mistake here. It will be catastrophic. But you know what? Since we're verifying the point, it's actually not that bad. We already know the answer. So if you don't get the right answer, you just have to find your mistake. Now, that's easier said than done, but you just got to find the mistake. So this is 25. This will be negative 25. This would be, you know, I'm scared now that I said a mistake. I'm going to show all my steps. This is 12. 12 minus 25. Yep. So negative 13/2. Okay, so we have the right bisector of AB. That didn't take too long, right? But now you gotta do all the steps. Okay, so that's the right bisector of AB. You gotta do all the steps again. This time for the right bisector of BC. Okay, 0 plus 6. Actually, BC is a lot easier. I'm looking at the numbers and there's a friend. So this is 3, 4. The slope of BC is equal to 0 minus 8, 6 minus 0. That's negative 8/6, which is negative 4/3. So this perpendicular slope is 3/4. Since B is 0, 8, therefore, oh wait a second. Actually, I can't. No, it's I missed off. I thought I had the y-intercept. I don't. So y equals mx plus b. So let m equals 3/4 and sub in 3/4. Oh. I actually don't know that. Like, I don't know if I'm on the right track, so I'm crossing my fingers I did not make a careless mistake. That would be very sad. So 16 minus 9. So b is 7/4. Therefore, y equals 3/4 x plus 7/4. Whew. Okay, so we have the two right bisectors. I just need to know if where they intersect. Well, how do I find where they intersect? Oh yeah, I have to solve a linear system. So I'm gonna solve this linear system, and I'm crossing my fingers. It's this answer right here. You know what? Let's solve that linear system. There's no way around it. So this would be, it would be very similar if we did a centroid question. You just solve it. So 1 to 2. Okay, I'll multiply everything by 4 just to clear the denominator. So this will be negative 10x minus 26 equals 3x plus 7. This will be negative 13x and then 33. Oh yes, I see a friend. Yes. Let x equal negative 33/13 for equation 1, let's say. Bam, okay. Therefore, circumcentre, let's say, of triangle ABC is negative 33/13, negative 2, 13. And hospital should be built there in order to be equidistant from all three towns. Okay, so that point is a circumcentre of triangle ABC, and that means the hospital should be built there in order to be equidistant from all three towns. I always ask this question when we do this. Should we build a town there? I mean, should we build the hospital there? Is it fair to build equidistant to all three towns? Because what if one town, let's say town A, is much more populous than town B and town C? Then I guess it wouldn't be that fair, right? Anyways, that's a whole different question, but that's something for thought, because you should ask yourself, how do we choose the location of the current hospitals? That's an interesting question. But anyways, that's not math related, but in this lesson what we did was just verify properties of a triangle. There's 4 different properties we talked about, and we did some questions regarding each one.